Researchers at MIT have made significant steps towards creating robots that can reconfigure and potentially build almost anything, including things much larger than themselves, from vehicles to buildings to larger robots. This new work from MIT's Center for Bits and Atoms builds on years of research on robotic devices that could be built to carry out assembly work. Now, the team has shown that both the assembler bots and the components of the structure being built can all be made of the same subunits, and the robots can move independently in large numbers to accomplish large-scale assemblies quickly. The identical subunits are called voxels. While earlier voxels were purely mechanical structural pieces consisting of plastic and magnets, connected by bundles of wires to their power source and control systems, the team has now developed complex voxels that each can carry both power and data from one unit to the next. This could enable the building of structures that can not only bear loads, but also carry out work, such as lifting, moving, and manipulating materials, including the voxels themselves. The robots consist of a string of several voxels joined end to end. These can grab another voxel using attachment points on one end, and then move inchworm-like to the next desired position, where the voxel can be attached to the growing structure and released there. As these robotic devices work on assembling something, they face choices at every step along the way. Part of the work the researchers have been focusing on currently is creating algorithms for such decision-making. The software they developed allows someone to input a mathematical description of the desired shape to be constructed and get an output that shows the robotic devices where to place the first block, and each one after that, based on the distances that need to be traversed. While the experimental system can carry out the assembly and includes power and data links, in the current versions, the connectors between the subunits are not strong enough to bear the necessary loads. The team is now working on developing stronger connectors, which involves fine-tuning the force of the actuators and the strength of the joints. Although a fully autonomous self-replicating robot assembly system is still years away, the researchers say this new work makes important strides toward that goal.